It's our last shot. It's the fifth and final time. It's our last shot to extend Hubble's life and bring it to the apex of its scientific capability.
And we just have lots of things we want to repair on Hubble and upgrade on Hubble, and not a lot of time to do it.
And we're going to take up everything we can take up. And on this flight, it's about 23,000 pounds of hardware.
This is going to be a very exciting, complicated, and challenging mission. We have 7 brave astronauts who've made a conscious decision to risk their lives in order to continue the advancement of science that Hubble has begun. They're going to buy another 5, perhaps 10 more years of lifetime for this great telescope.
We've got a full plate of things to do. We've got major science upgrades that we're going to do. So we have 2 new science instruments that we're going to install.
We're going to put in the cosmic origin spectrograph. And this is, the fanciest spectrograph that's ever been put into Hubble.
COST plus Hubble together will be able to observe deeper across the universe than any other instrument of this kind has ever done before.
Well, we're going to install the Wide Field Camera 3, Hubble's new imager.
Wide Field Camera 3's discovery factor is about 10 times better than the current instruments that we have on Hubble.
One of the beautiful things about our new camera, the Wide Field Camera 3, is it will be capable of looking farther out across the universe and farther back in time and closer to the Big Bang than any other camera we've ever had on Hubble before.
We're also going to attempt 2 repairs of the 2 failed instruments on board Hubble, the Advanced Camera for Surveys and STIS.
ACS was inserted on Hubble in 2002. Before it died, it was the most heavily used instrument on Hubble. And STIS was our first black hole hunter. And it went on to do the first detection and chemical analysis of the atmosphere of a planet around another star. We want to keep on doing that kind of work when STIS comes back online.
This will be the first time that we've ever done an in situ repair of science instruments. So this will be a big challenge.
In fact, there's 110 of these very small screws that we need to remove from the instrument in order to gain access to the board we need to replace. And in space, things float, and debris is a real issue.
If we're successful in repairing these 2 scientific instruments that have failed, it will be a real triumph for NASA engineering and will point the way toward our ability in the future to repair instruments in space. We want Hubble to last a while longer as a spacecraft. And since this will be our last opportunity to go service it, we're going to do things like change out all the gyroscopes that help Hubble point. We're going to put in a new fine guidance sensor. I say a new fine guidance sensor. In fact, it's a refurbished fine guidance sensor. It's one that's been on Hubble before and been brought back to Earth, refurbished it. So it's a used fine guidance sensor, but first class. We're going to change out our batteries. Never put in new batteries since Hubble was launched.
We have some insulation repair work that needs to be done.
We're going to install a new outer blanket layer called a noble, which is a solid. It's not a blanket anymore. It's a solid sheet that will go over the blanket.
And we'll also be installing a soft capture mechanism on the aft bulkhead of Hubble that will help facilitate a future mission to Hubble, primarily for the purpose of deorbiting it at the end of its useful life.
The 2 repaired scientific instruments working in tandem with the 2 new instruments that we're going to put on board Hubble in this mission will enable scientists to tackle some of the most profound issues facing modern science, not just astronomy, but physics today. This, in my mind, means that when the astronauts leave Hubble after servicing Mission 4, it will be at the absolute apex of its capabilities. It will be better than it's ever been before.